Let's go right into it. Live. Nice. Hello, hello. So, guten Abend. Okay. So, hello world. We're here. And what we're going to do is continue where we left off from problem 150 from the other day. I had an idea about how we can generate these palindromic numbers. I think I'll implement it now. So palindromic numbers, palindromic number, integer. A palindromic number is a number that is the same when written forwards or backwards. All right, 399, 14341. Write a function which takes an integer n as its only argument and returns an increasing lazy sequence of all palindromic numbers that are not less than n. The most simple solution will exceed the time limit. So, gotta use a solution that's not naive here. And okay, so I have an idea. It's somewhat better than naive, but it's still relatively sort of trivial solution. And it goes something like this. Let's build the scaffolding first for this question. What do you think we're gonna do here? Let's go with what do I want to call this? Palindromic. It's just palindromic numbers. Let's just say, what is our function going to do? It's going to take, generate a sequence. So we'll just call it palindromic sequence. And it takes lower bound, we'll call it. Oh, not what I wanted. Yeah. Put this guy over here. Put this guy over here. Put this guy down there. Paste these in. So some test cases to work with. Also can do this. Okay, hold on a moment here. Oh, never mind. Never mind. Okay. Good. Got those. And we got this. I'm going to add a extra parentheses each of these. Okay. So we also want just like the printout as well while we're testing. Which we expect to be this. Right. And then we also want some rationale here. So what we're going to do is we're going to iterate. Define some functions here. And what I want to do is start with the lower bound as the, so call this, not reduce, repeat, not iterate, but iter, call this iter func, I don't really know what to call it exactly. But we'll say previous. And what we're going to do is, I kind of want something like this, which is just iterate, iter function over the lower bound. And this iter function is going to have something kind of interesting going on. We're going to create a string out of the previous. All right, so it's an integer. Create this a string out of it. Now I'm kind of wondering if this is the right way to do it. I mean, this will work okay. This will be fine in the test cases that we're looking at. The tricky thing here is this is supposed to be a lazy sequence after all. There's a tricky thing here, which is you can create the initial starting point, which is an integer. Nah, it doesn't matter. Never mind. No, there's nothing tricky. No, never mind. Okay, no, this is fine. So what I was going to say is that you could have some internal state, which represents like a counter kind of a thing, where you have a number that's going to be mirrored, right? So you keep incrementing that number, and then the mirror is what you see in the sequence. But, excuse me, but realistically, if you iterate step to step over, I mean, you could still do it this way. Yeah, okay, I'll do it this way, okay. Yeah, okay, we can still maintain that way if it really bothers me that much. I could say left mirror, lower bound, iterate, consider function, left mirror, previous. You really don't even need the previous. I mean, it doesn't even really matter. It just how do I want to do this? It's kind of like, okay, let's do it this way. So we'll just call this initial. Say initial infimum. Right, the initial infimum is going to be I don't know, it's kind of confusing what we're doing here. Initial infimum is going to be the initial left mirror we can get, then we can parsing an integer, yeah. String to int. Parse int. That's not really what I want. Integer parse int. Okay, well, fine. We'll use that. Gotta think about this. So, shucks. What I want to do is take the integer, convert it to a string. If it's even, take the left half. If it's odd, take the left half as well as the midpoint. I want the left half concatenated with the midpoint, concatenated with the left half reversed, right? You have to do it this way. Left mirror, midpoint, and then there's another value here, just initial infimum. The way that I'm trying to do it. Yeah, okay. So something like this. Initial. Excuse me. Let's have this lower bound. We can say initial bound string of lower bound, and then we say something like initial left mirror and midpoint depends on whether or not we're looking at a if the count is even. Right? Number of characters is even or not. If there's an even number, then we can then we can return take half of I think and then convert that to an integer. Yeah, these are the kinds of things that, like, the more time you spend with the program, the more you can optimize it, the more you think about it. Kind of don't want to spend so much time thinking about it. Also, if you have more experience as well, it's sort of optimize sooner, faster. And I don't mean the performance, I mean the, yeah, somewhat the performance, but also the, what's that called? Number of characters. Optimizing for, like, semantically speaking, the semantics of it. So, initial left mirror, initial bound size, even. So let's say it's 4. All right, it's the number of characters, and you take 2 of those. characters. Parse an integer out of it. This will create a sequence also, which we want to actually join this. Even if it's not even, if it's odd, you still want the first, yeah, okay, let's do it that way. Really only matters about the midpoint. So you want, really this should just be here. And this will always be the same. And it's going to be, turn this into, say, math floor int. And this is going to end up being a, what do they call that? So initial bound is a string. You're going to call, oh, interesting. Huh. That's another one, I guess. To this function, which is going to be, what is this? This is initial bound size. It's going to be divide initial bound size by 2. Then apply that to math floor. Apply that to int. Get that thing. Then you're going to take this result. Oh, this is confusing. Right. Okay, you want to get this number here, right? And then you want to take that amount from here and then parse the integer of that, which you also want to Clojure string join on this thing. Confusing as that is, holy smokes. Yeah, that's definitely real confusing. Wow. Let's just do this. Let's say initial left mirror size. We'll do this. Right. And then we want to take initial left mirror size from initial bounded string, and then we want to join and parse an integer. Join this integer parse int. And using the threading macro, we can make this a little bit cleaner by saying we're going to feels a lot more complicated than it needs to be for whatever reason. Okay, so we get half the initial bound size as a string, right? And then we get the sort of left half of that initial string, right, as an integer. And then we say, okay, this midpoint is going to be as follows. If we're even our initial bound size, then we're just going to be empty string. Otherwise, we're going to actually take the nth value of this string, which is its initial bound size, or initial left mirror size, right? I want to get the index there from the not lower bound, but the initial bound as a string. Right, initial bound is string. Let's go look at nth. Nth. Collection index. Should throw an exception, I think. Correct. Yeah, we should throw an exception if we don't have this. Alright, so that'll be our midpoint. And so we get our left mirror, initial left mirror, we get our midpoint, and we say, okay, initial infimum is going to be it's going to look something like this. It'll be a loop. And what we're going to do is start with left mirror, initial left mirror, and then midpoint, midpoint, and finally, yeah, we have this initial left mirror, midpoint, midpoint. Let's call it mid. All right, and we'll call these a let here. We'll get palindrome is going to be concatenation of the string left mirror, midpoint, or mid, reverse string of left mirror, right, this whole concatenation, and then finally really should be string instead of join. Parse that integer. And this should also be parse big int, really. Does that automatically work? Okay, so there's big int. Okay, begin. Oh, that's cool. You can big int of an integer of a string. Oh, that's awesome. Let's use that. These integers will get real big real quick. Just by the way. Okay. Put everything in big ints, I think. This probably doesn't need to be big int, actually. The counting of the sides. It's got a left mirror, we've got the midpoint, initial infimum. We're going to get the palindrome by taking left mirror as a string, the midpoint, and reverse of the left mirror, and then coerce that to a big integer, and then we say, and then the recurrence is going to be if this palindrome as an integer, if this palindrome is greater or equal to the initial bound, not as a string, but just the initial bound, lower bound. Right? It's greater than or equal to this lower bound, then return it. We actually don't want to return the initial infimum. We want to return two pieces, which will be the initial left mirror. You rename this to initial left mirror, and also rename the initial infimum here, which is the palindrome. And this will be the left mirror. Otherwise, we're going to increment the left mirror to create the next palindrome. And the midpoint we're going to determine as well. In this part, we want to sort of put that, no, it doesn't have to be on the same line. So what this will look like is it's initial bound size. So we want to say initial left mirror. We kind of want to say the palindrome size. Palindrome as string. We actually want, now this is kind of a tricky thing. I'm doing this wrong, actually, now that I'm really thinking about it. Might be one of the reasons why this seems really complicated. I don't have a clear picture. So part of the problem is we've got this initial mirror, and we're just going to double it across to get the palindrome. But the problem is, what about when you're dealing with the odd sequences, right? Like this is only going to ever generate even palindromes. There are such things as odd palindromes, and we're not going to generate the odd palindromes this way, which I did not consider. Did not think of that. I guess there are two midpoints that you copy across. Yeah, I guess there's two. Use this mirror in two ways. Shucks. Oh man. Oh, this is real awkward. No, this is so much more complicated than I thought it would be. No. All right, if we do something like 1, 2, 3, 1, 2, right? Something like this. Consider this palindrome as like the lower limit, right? Lower bound. So everything's got to be larger. Every palindrome's got to be larger than this one. Okay. So all of your palindromes need to be larger than this. It's also incorrect. So the thing is, you would start with 1, 2, 3, and you copy across this 1, 2, and you get 1, 3, 3, 3, 1, and you know, with this midpoint not changing, 1, 4, 3, 4, 1, etc. Right, all the way up to 999, 3, 99. Now the problem with this, right? The issue is the problem with this is there's a few issues here. For starters, when do you ever upgrade this midpoint? When does that ever change? Right, because clearly you can have almost exactly the same thing. 1, 2, 4, 2, 1, all the way across, all the way down to 999, 499. And actually, these are sort of interwoven in between, right? You need to kind of go from here to, right? You actually really should be changing the midpoint first, and then cascading the change from the midpoint upwards. Once this is a 9, then you go to the next. Then you go to 3. So really, yeah, really, it's this is the number that should be incremented. And maybe you just grab from this number sort of the mirror if the number is odd or even in the number of digits. Yeah, okay, could do it that way. That's fine. I guess it's not that complicated then. Right, because I'm thinking like algorithms to compute addition and carry over and stuff is kind of annoying. I don't really want to. Excuse me. I don't really want to mess around with that too much. So actually, you want to do it this way. You want to say initial bound is a string. Get the bound size. At the not the left mirror size. You want to say the left mirror size is going to be not the floor, but the floor plus 1. I think if it's even, right? So you have 0, 1, 2, 3, 4. You have 4 characters. Take the size divided by 2. You're going to take 2. If it's odd, you actually really just want the ceiling. I think ultimately, right? 4 divided by 2, you take 2 characters. 5 divided by 2, you take 3 characters. Yeah, okay, fair enough. Left mirror size, and then you say you're going to take not the size, but if it's in this part, it's going to be if this size is even. Well, no. You do take this mirror, right? You take it, yeah, that's fine, because then you get that integer to work with, right? And then the midpoint, we say if the mirror size if this is even, there's no midpoint. Otherwise, we want to say, I don't know, mirrored component, we'll call it, or component to be mirrored, and the midpoint. So we'll say if the initial left mirror size is even, or the count of this mirror then we want, if it's even, then we can just say leave it as it is. Otherwise, you're gonna want do it this way. The last of value, right, from left to right. Don't need this nth. And then also, this is going to be remove the last, drop last, but last on this guy, which is kind of unusual, kind of interesting. And this actually has to be converted to a string. This is an integer. Interesting. This is kind of confusing, man. To be perfectly honest with you. So I don't know what to do here. This is like, what is going on? What are we doing here? Mm-hmm. Mm-hmm. Also, I'm thinking of cases where if you have 3 digits and you add 2 more digits, you have 5. If you then jump to immediately to, why wouldn't you just there's another thing that's immediately not making any sense. No. As it turns out, the sequence of palindromes is a bit of an elusive sequence. It hasn't been like a really solid way to generate the sequence of palindromes. I believe. I don't remember exactly, but I remember it's not like the simplest thing in the world, I guess. I just realized that if we have if we're using 3 numbers, there are palindromes with 6 digits where you can copy 3 across. There are also palindromes with 5 digits where you copy only the first 2 digits across. And the same the same number generates both of those possibilities when you mirror it across using this algorithm that we're looking to employ here. I think I'm just gonna go lay down. This is way more complicated than I'd like it to be. It's way more complicated. Just have to remember that I put this here. Oh, shucks, man. Shucks, man. Oh. I don't know. Spend a few minutes. Set a timer for maybe 15 minutes or so. Let's give it 20 minutes. Let's give that one 20 minutes. Also, this charger doesn't seem to be doing what I'm expecting here. Oh, what a headache. Not a headache, but just... I don't know. It's weird. It's like, I don't know why I guess I'm upset. I don't want to admit it. Why would you get upset over a math problem? What's wrong with you? I guess because I feel like there's a lot of pressure, and I'm kind of like, hey, I really, really would like to just finish these problems and move on. But realistically, any problem that you deal with in the real world is going to have a similar kind of, I don't know, taste and texture, where it's, it's not comfortable, it's not easy. It's just a whole bunch of things involved. It's complicated. It's just kind of normal. It's just how it is in life, in reality. So anyway, excuse me. So the thing here, thing to consider is what? All right, so this idea of using a kind of like a seed, you know, that starts off like, all right, here's the palindrome sort of root, and we're going to increment that root and keep sort of spawning more palindromes from that spot. That doesn't quite translate so nicely because, like I said, if you have two digits, you could spawn palindromes that have the first digit copied across, right? The second digit it just is steady, stable, whatever you want to call it. The last digit doesn't move, but all the other digits get copied across that middle digit. Those are palindromes. And then you could also copy all the digits across, right? You have two different options. Now, the tricky thing with that is it's not entirely clear the order that these things will be generated in. Well, clearly each time you increment, so you'll end up with two sets, I suppose, so two sets of palindromes. One set is always going to be smaller than the other set, I believe. Well, not quite. I mean, you kind of want to interleave these two, I guess. No, you don't even want to interleave them either. There's a period of time where, so for every sort of quote unquote seed, we'll call it, there's going to be two values, and we always know that one is smaller than the other, right? The one with more digits will always be larger, and there will always be one with more digits. But the problem with that is, at some point you end up with, to generate all these 4-digit palindromes. So I guess we start with two numbers, right, or two digits, and we generate palindromes with 4 digits and palindromes with 3 digits, or rather the other way around, palindromes with 3 digits and palindromes with 4 digits. Okay, all of the ones generated that have 3 are going to be less than the one generated by 4. And they're also sorted in order, right? In the order that you generated them, right? So the smallest of the 3s is the first one you generated. The largest of the 3s is the last one you generated. Everything in between is sorted. Okay, that's fine. That's all well and good. But the problem that you run into is that you've got to concatenate these two sets before you start looking at the next sequence of palindromes, because the next sequence of palindromes, you'll have 5 and 6 digits. No, actually, that's fine. That works out okay. It's simple enough, right? You can just concatenate, based off of how many digits you're working with. I mean, okay, I suppose. Yeah, but this doesn't quite give you. This doesn't map so nicely to that lazy sequence that we were describing that the function actually wants, right? Like, this doesn't give you immediately the next value. We could strictly generate only the 3-digit palindromes, but then we'd have to go all the way back to the 4-digit palindromes. And I don't even know how I would do that. How does that work? This is not so obvious, It's not the most obvious thing here. And how do you make this sequence lazy? That's the thing that's even more challenging. It's like, it's not obvious how you can do that as well. Alright, well, we gotta sit and ponder here. Sit and ponder. No other choice. Spend the time. Spend that time. Ain't no other way. Ain't no other way. Must be done. One way and one way alone. Let's think about it. Okay. So I was kind of sitting and thinking for a while now, and I came up with some conclusions, some thoughts, some ideas. What were they? Where are they? Well, maybe I've just forgotten them already. Not entirely sure. I am not entirely sure. Huh. Alright, I didn't make a lot of progress thinking about this. Still kind of thinking about it, mulling it over, pondering it. Shucks, man. I can set up the starting point. Let me also just so you guys have a background to look at. You can see the problem that I'm looking at. No, not that. One of these. There it is. Oh, it's me. Hello world. Yeah. What we're looking at is these palindromic numbers. What can we do? Well, like I said, we can generate those seeds that would generate parts of the sequence, and then we can connect those parts of the sequence together. Like, that's fine, but that doesn't give you the lazy sequence that you're looking for. Not quite. Not exactly. I wonder. Maybe that's fine. Maybe it's exactly. Maybe it's okay. I'm wondering. Maybe it's just a concatenation that we return. The concatenation can be lazy. That's fine. Kind of concatenation of concatenations. Huh. I wonder. Yeah, when you're using this sort of seed number to generate the palindromes, you're going to want to generate this. You get this sort of seed number, you generate these palindromes. You're going to want to. What do you do? I guess what I'm thinking is that maybe you can provide like another parameter that tells you whether or not you should be generating the digits of size 5 or digits of size 6, sort of thing, like sort of a number that'll tell you how many digits you should be generating, and flip between that. I'm wondering also if just a simple concatenation of these things works as well. There is a problem of, like, once you've looped all the way through sort of the seed, right? In other words, you increment, or you repeatedly increment the seed, and then that generates, you can use that to generate either sort of 2x minus 1 or 2x digit size palindromes with that number of digits. The tricky thing there is for one, you need to jump to the next category altogether. You need to pay attention to that, I suppose. And then you also need to consider, I guess, this lazy sequence of, I don't know, concatenating these two sequences. They're kind of like two separate iterations. This is kind of interesting. I mean, there's sort of like concatenation of finite sequences to generate an infinite sequence. It's kind of what a sort of like a piecemeal sequence type of deal, which is, it can be done, like, I guess. It's not like we can't do this. It's just, it's a little awkward, I suppose. Can it be done? I don't know. I don't even know. Thinking. I guess you got to have a point where the iterate just stops, right? Which is not how the iterates work in Clojure. They don't just stop typically. You can have your lazy sequences stop. You can generate these lazy sequences. I suppose that works. Concatenate two lazy sequences. And then concatenating these two lazy sequences that are generated from this this particular seed, and then those have an end where the seed increases the number of digits, and then you get a new. That's kind of tricky too, huh? I don't really like any of that. All that seems way more complicated than it needs to be. Like, I feel like there's got to be a way simpler approach to this to generate these palindromes. I don't think so. So there may not be an easier way, simpler way. Maybe you generate. Oh, maybe this is the way to do it. Maybe it is really a little simpler than I realized. Huh. Well, even that is kind of like, I'm not sure. Okay, how about this? All right, I think I got it. So you've got one sequence that you iterate over that generates all of the palindromes that are at least a particular n, at least the size of a particular n, and those only have an even number of digits. Then you have another sequence that only has an odd number of digits, and you can't just interleave these directly. That won't work, because then you'll get 1 digit, 2 digits, 1 digit, 2 digits when you want all of the 1 digits, all of the 2 digits, all of the 3 digits. So it's not quite. It's more like you have the sequence of sequences, sort of a sequence of subsequences that you want to interleave those. So you could generate the sequences with 1 digit, an odd number. So you want the sequences of odd palindromes of an odd number of digits, and those are sort of subsequences. Then you would interleave those sequences, and then you want to flatten all of that, concatenate all of that, actually, not just flatten, concatenate everything. Yeah. Okay, so you can use a concatenate and an interleave over, so this iterate is going to give you each of the sequences, I think. Oh, hello. Did we disconnect? Uh-oh. I get this feeling we had a small issue here. What happened? Not receiving a video. Nice. All right, let me reconnect here. Hold on, everybody. Also, man, I'm due for a haircut. Okay, we're back. We're on my phone's internet though. which is not great. It's better, but it'll do. But yeah, let me go ahead and put the display back on here. Yeah, so my thinking is such, right, as described. We can use a small routine. You can use a subroutine that will generate the sequences of a given number of digits, and I'm not sure if it even matters anymore, whether or not. I'm thinking about it. I don't know if I need to do this interleaving with the sequences. I mean, I could just generate them straight out the gate. Yeah, I mean, generating the palindromes with a certain number of, if we break it up into the number of digits that we're generating, and then you could even just have each of so that particular subroutine could take as a parameter, like, oh, this is how many, this is the smallest, what do you call it? This is like the lower bound on the palindrome. So all the palindromes that you generate need to be at least as large as this. You do a simple check. It says, look, if you don't have enough digits, then you just have an empty sequence. Right, obviously, if the palindromes that you're generating for that particular sequence, the number of digits you're going to have, if it's if the resulting number of digits is smaller than the lower bound number of digits, then you can skip that sequence, right? And obviously that constitutes an order of magnitude, right? Those palindromes. So you'll very quickly reach your lower bound in logarithmic time. You only have a logarithmic number of sequences to generate, so you have a logarithmic number of hops. So that's efficient enough, especially for these use cases. And then you also can say, okay, the palindromes themselves, it's not logarithmic. I want to say it's square root in the number of digits, something like that. It's so basically you would loop through, like, okay, you want to generate all the palindromes with 5 digits, right? You have three numbers, and you increment that number and copy the sort of first left 2 digits across that number to generate all the palindromes with 5 digits. That's sort of right, assuming that you're not going to have anything that, assuming these are all integers, they're not palindromic strings. That's the way to do it. So yeah, you would start at, I guess, 100, and you would loop through all the way to 999, and there you go. That gives you a little under 1,000 palindromes. So that's 10 to the third, whereas the number of digits, right, would be 10 to the fifth. If you see what I'm getting at here, it seems like it's a square. It seems like it's half the number of digits, sort of 10. So if you're looking at palindromes of, I don't know, k digits, then it looks like you're going to have to loop through 10 raised to the k over 2 different numbers to generate all those palindromes. Like, that's how many palindromes there'll be. With k digits, there'll be square root of. So I guess it would be. Yeah, it's the square root of sort of 10 raised to the k, which actually, I guess, is exponential. The number of digits that you're looking for. But it's not exponential with regard to, if you're not given the number of digits, but you're instead given the number, then it's actually, yeah, it's proportional to the number, right? Because the number, you would take the logarithm to get the k digits, right? So log base 10 to get k digits. So then you would, rather if you're given n, k is then log of n, and then so then you're looking at 10 raised to log of n over 2, which is square root of n. Okay, yeah, that's doable, that's workable. So you have square root of n palindromes for a given sort of number. But even that is not really what we're looking for. We're looking for specifically just a sequence of palindromes. Like, we don't even care how many of those palindromes there will be. You know, as long as it's a lazy sequence, doesn't matter. Right? As long as the number of palindromes that we pull out of the sequences is relatively small, then it's fine. So yeah, so actually this will work. I mean, it's not super naive and not super complicated, but doable. You know, it's doable. Not too bad, I think. But yeah, what it comes down to is you're going to have a function that generates a lazy sequence of palindromes. It'll take a few different numbers. One of those numbers is a lower bound. Another number is the number of digits that you want in that palindrome. And what else? Now, there is a question, though. How are we going to handle throwing out the palindromes that we're not interested in? Right? Because, well, that'll take square root of n time. That should be fine. Yeah, that should be okay. All right, suppose that this subroutine would constitute all, like, suppose all the palindromes that we're interested in is in the same sort of subgroup, right? I said each of these subgroups can be relatively large. It's about square root of n size, where n is the I guess 10 raised to the number of digits that we expect to be in our palindrome, something like that. Something like that. And if we do this, how long will it take us? Yeah, within our if we just keep dropping, if we just do an iterative search, well, it doesn't have to be iterative search, right? It can actually be really fast. It could be almost immediate, because we can just, like I said, we can just take that lower bound and manipulate it to give us sort of an entry point that's very close to the beginning of our sort of sequence. So it really doesn't matter. It really just doesn't matter that much. Okay, so all right. So one more time, we're going to have a subroutine, which you'll be given the number of digits we expect in the palindrome, and you'll be given the initial lower bound, right? And then what you're going to have, once you've got that subroutine that returns all the palindromes that are at least as large as the lower bound, that are also have the number of digits that you gave it, right? You can then concatenate those sequences and then return that as what we're looking for, right? That other concatenation operation. As long as the subsequences are lazy, then the concatenation of those subsequences is also lazy. Yeah. So okay. So then how do we concatenate those subsequences? Well, first things first, we don't actually know we don't actually know. Now that's the thing I'm wondering. I'm wondering if, hmm. I'm wondering if we can do it this way, because we don't know how many sequences we're going to concatenate. That's actually, there's a variable number of sequences to concatenate. And it's not clear to me whether or not if you apply a concatenation over a series of subsequences, if you'll still be lazy. I don't know if you still get that property. I'm kind of hoping you do. I think you'd probably do, but I don't know. We can test that out in the REPL. I actually could do that right now. I could find out. I could find out right now. Now got to be free. Setting open calls for the virgin seas. Yeah, so I kind of just started coding. It's kind of silly. That was a little silly. I've got to be free. We apply concat of repeat range. Take 5. Oh, it works. Hey, check me out. All right, cool. So yeah, no problem. You can lazily concatenate even infinite sequences. I wonder what happens if we do this. That won't work. Because there's an infinite number of... This will try to take the first element from an infinite number sequence of sequences. It'll take the first element of each of those sequences. Yeah. No, that's not going to work either. It was also incorrect without, you needed a function here, but still. Apply, or if you, that wouldn't be apply, it'd be map. Yeah, none of those will work. I think these two don't work because they don't make sense, but then this one doesn't work because you end up with an infinite thing you're trying to take. So okay, so yeah, you can apply concat. That works. All right, great, cool. I want to check that. So now let's think. Let's ponder. So let's go back to the problem. Let's go back to our problem. What we have is right. So okay, so we can. All right, great. I think as described that'll work out. Number of digits that we expect, and the lower bound informs the starting point. Now, how? And we just concatenate those sequences. Generate. I guess it would be concatenation of those, and it would be an iterate. You would iterate through these sequences. I suppose. Actually, I don't know. How would you do this? You have. Well, like, would you just get all of those? Like, how do we want to generate all of those sequences, right? So, yeah, I guess the iterate would be. No, wait a minute. You actually want something that generates that sequence of those things. So it would be, what would that look like? Lower bound wouldn't change between the function calls, and then the only thing that's changing is the number of digits. Right, it goes from 1 to 2 to 3, etc. Just increments. I suppose I mean, you want the lazy concatenation of those sequences. Yeah, sure. But what generates those sequences? Yeah, you apply concatenation over the result of, I guess, some function that is going to generate each one. Yeah, I guess you could just create a quote-unquote lazy sequence that, like a function that does lazily generate one after another. And I guess it'll just do it infinitely. Doesn't even take any inputs, I suppose. I guess the only input it would take is the lower bound. Interesting. Never actually, what's the word? Never actually terminates. Huh. Yeah. I guess so. I don't really know. Just cons and cons the next iteration. Can we do that? I could try that. That'd be kind of neat. Yeah, okay, it's fine. So it's a construct that would just be like a lazy sequence of cons, sort of call that function that I described, and then what would be cons with on the sort of the rightmost element, rightmost parameter argument would be just the the function name again, same function call. But I suppose with an incremented, I guess it would have to take the initial value of like how many digits you're going to produce this time, so to speak. I guess that works. Just seems kind of like maybe there's a better way to construct this. Could do it this way, I suppose. There's probably some construct they already have, like iterate is kind of what I was hoping for, thinking of. But no, it's not really iterate. That's not really the one we're looking for either. Maybe map is what we want. Oh, there we go. That works. Yeah, map works. That's better. That's way better. Sorry. Yeah, no. What am I doing? You could just map over range, or range is an infinite sequence from zero to infinity of the positive numbers, including 0, and then you just have a what do they call that? A lambda expression, or a anonymous function. I'll take that as an input, right? So you map to each of those values this function that lazily generates the and you can even call it mapcat instead of just map, right? Mapcat will also give you lazily what you're looking for. Yeah, that works. Okay, never mind. We don't need to do all that other fancy shenanigans. As you can tell, still getting kind of used to thinking about how does one manipulate data in a functional way, in a sort of using like infinite sequences, infinite and lazy sequences, rather than like the standard sort of imperative finite kind of manipulations that you would do. So so then okay, that's pretty easy then. Then all we need is our function that will generate, given number of digits, given a lower bound, generate all the palindromes of that particular number of digits. Also, only returning the palindromes that are at least as large as the given lower bound. And yeah, so what would that routine look like? Well, if you have an odd number of digits, so you can generate the starting point, and this is supposed to be lazy, so it's also kind of interesting, I guess. How can we ensure that the laziness of that particular function as well? There is a difference between if it's even or odd, the number of digits that you're working with, but that's fine. I mean, that's not really much of an issue, right? Because we're given the number of digits that we're targeting. I'm thinking we can also use a range again. So let's say it's 6 digits. Let's say it's 5 digits we need, right? Palindromes of 5 digits. We're going to say the starting range will be what's that? 5 divided by 2. Ceiling gives you 3, right? And then you take 10 raised to that, the third. So no, excuse me. Subtract 1 from that. So actually, it's going to be the ceiling minus 1. And you're going to take 10 raised to that power. So 100, right? That'll give you 3 digits. That's the starting point. You have a range from 100 to, I guess it would be 10 raised to the third minus 1, so 100 to 999. So that's how you can get your range. So you have this range of integers, and you're going to map over this range of integers this sort of palindrome function, which will take, now if you have an even number of digits, you just convert this function you're going to get, this lambda, or this whatever this function you're going to use, it's going to take, if it's even, it's going to take your integer, convert it to a string, reverse the string, and concatenate those two things. And that'll give you your resulting palindrome. If it's an odd number of digits that you're looking for, then you're going to convert this to a string, but then what do you do? I guess you convert it to a string. I'm thinking if there's a clever way to do it. Not really, is there? Yeah, convert it to a string, drop the last value, reverse that, what you've got, and then concatenate all that back together again as a string. Also, these things, by the way, these are supposed to be numbers, so all of these things, after you've complied this function, you actually want to convert it back to an integer. Right, so with even number of digits, you're going to convert to a sequence, or convert to a string, reverse and then concatenate that with its own reversal. Whereas if it's odd, you're going to convert it to a string and then concatenate it not just with its reversal, but drop the last element. Or actually, no, even better. You can reverse it and then drop the first element. Oh, I didn't think of that. That's even better. Right, convert to a string and then reverse that, and then take that, concatenate it with its reversal with the first element dropped. Right, and then that can be also converted back to it's got to be concatenated and it's got to be converted back to a big integer, not just a string, but converted to a big integer. Okay, yeah, that's fine. Both of those work out nicely. And then that just whichever function you're going to use depends on whether or not it's an even number of digits that you're working with. Okay, but we still haven't addressed the lower bound, right? Excuse me. Obviously, we can just drop elements from this sequence. We could filter on elements that are less than this lower bound. But we want to do better than that. We don't even want to compute those elements in the first place if they're smaller. I'm not sure if I really can do that realistically, thinking about it now. My initial idea was, well, you can take the lower bound and, oh yeah, do it that way. That's even better. You can use that lower bound to inform the lower bound of the range that you loop over, right? So if the lower bound is, yeah, I don't know, well, it doesn't, well, okay, if the lower bound has fewer digits than the number of digits you're looking for, then you're going to default to, what was that number I came up with before? In this case, for 3 digits it was, or for 6 digits it was 100, right? So you kind of have to take the, yeah, if your lower bound is lower than the number of digits that you're going to be looking at, it doesn't matter. You can effectively ignore it. And in that case, you would have to default to you still have to compute the one that I was describing before, and just use that. So I guess it'd be the maximum of these two values. But if it's the number of digits in the lower bound is larger than the number of digits you're looking for, then it won't matter as well, because that will break your range. Your range will just be empty, and so your mapping will return empty, and that's exactly what you want. You want an empty set, so that you can ignore that too, in that case. And finally, you have, if they have the same number of digits, that's the only case you really care about. The other cases are handled by just taking the maximum of this. You compute that default value, take the maximum of this value and that default value as the beginning of your range, and that should handle, right? And you still calculate the end of your range the same way described. That'll handle that, all that logic for the other cases. But the case that it won't handle is if you're lower, if the right, so I'm sorry, there's actually a small mistake there too, because this number that you're going to compute for the beginning of your range, you can't just compare it directly to this other number that was generated. This other number, or this other lower bound you're given, this other lower bound that you're given is the number of digits, is actually a palindrome itself potentially, right? Like, in other words, it has the number of digits of the things that you're looking to generate. So you can't just plop that into the starting range, because it's always going to, even if it was in the range of things that you're looking for, it would be too big because our range, we're ranging over sort of square root of that, something like that. So what you do is you lop off the first few digits, or the last few digits of that lower bound, and use that to inform the range correctly. Yeah, so that should do it. That should handle it. You have this default beginning, default end that you compute as described, and then you take, depending if it's odd or even number of digits. If it's an odd number of digits, it's an even number of digits, then you're going to take half of the first half of the lower bound, or convert it to a string, take the first half of that string, and then concatenate that and convert it to an integer. I guess a big integer. I'm not sure if you need to use a big integer for this part. Probably not. Convert that to an integer, right? If it's even. If it's odd, you're going to take convert it to a string. You're not going to take the first half. You're going to take the sort of, because it's odd, there's sort of a central value. You're going to take everything that includes the central value and everything to the left of that. So the most significant digits, and convert that to an integer as well. And that'll be your starting point. And now the tricky thing with that is it's still not totally correct, believe it or not. No, that might be correct, actually. That's the thing I'm not sure about. I think it is correct. I think that it is. No, it's still not totally correct, right? You still need to include in your, when you're looping over these palindromes, yet another check to drop, sort of a drop while, we'll call it, which will drop all of the palindromes that you generate that are less than the given lower bound. And the reason you still need that check is even though this updated range that we just computed is a lot better than the original range, it still doesn't cover all the, well, it doesn't give you exactly the beginning portion. It just gives you like a very good sort of starting point. I think it's probably one off in the worst case. I think it's very close to the. There's only a constant number of operations to the correct starting point. It's either directly on the starting point or just one below it. And the reason it could be one below it is, if you have like 1, 2, 3, 4, 5 is your lower bound, right? The lower bound doesn't have to be palindrome. So you could have 1, 2, 3, 4, 5 be the lower bound, and then obviously 1, 2, 3, 2, 1 is below that lower bound. But if you go to 1, 2, 3, 4, obviously you're immediately above the lower bound. And the reason for that is because the least significant bit of the bits you're using to begin the range, the least significant digit of the digits you're using to begin the range, are all more significant than all the digits, any combination of the digits that follow. So as soon as you increment 1, you're immediately above the lower bound if you missed it. If you were if you were below the lower bound, you're always going to just increment by 1 and then you're up there. Which you can even go so far as to say, well, you could just perform that check directly instead of using the drop while, which actually might be even better because that might be a little more concise. So yeah, you can compute the range that way, or the beginning of the range that way. Yeah, that'll do it. So compute the beginning of the range, and you're going to map over that range using, depending on if it's odd or even, a particular function. Also, depending on whether it's odd or even, the number of digits, how you compute the beginning of that range, and then that'll give you a function that's we'll use. So that can be done lazily. All right, that can be lazy. No problem there. I think the map function is naturally lazy. Anyway. Right, all those things are sort of lazy, and what else? Yeah, and then you can use a map cat over a lambda or an anonymous function, which uses this function that we just defined, and just the only thing that changed, and you map that map cat over the infinite range. And that'll generate all of those sequences that you're looking for. And yeah, there you go. It'll generate empty sequences for the sort of logarithmic number of initial sequences that you don't care about, right? And so you'll spend a logarithmic amount of time sort of just looping through those before you get to the stuff that you care about. And then then you got that lazy sequence beginning at exactly what they're looking for. Yeah, that could work. Kind of want to like go lay down again before I code it up. Yeah, just because I don't know. Why did this feel so much harder? Like something about this felt way harder than the other problems. I don't know why. I don't really. It's not by any stretch of imagination a difficult problem, but it definitely had me thinking. I guess it's because I'm like I said, I'm not used to thinking about things in terms of I guess I'm not used to thinking about things in terms of like these infinite sequences, combinations of these infinite sequences. And that's like because I'm unfamiliar, it's more challenging. Maybe that's part of it. These are also kind of deliberately made to be somewhat challenging, somewhat make you think, make you ponder. But yeah, this whole concept of like data wrangling, kind of code wrangling, and trying to manipulate infinite sequences. It's pretty cool, pretty neat, pretty cool. Definitely makes things more cogent. Yeah, neat, very neat. Get better at it over time, I think. I will improve over time. Yeah, so I think I'll go on to the next thing here, which is actually code it up and then go look at other solutions. And that's fine. That's all well and good. I think also I can connect back to disconnect from my phone's internet here. I think I'll do that shortly. Huh. Oh. Wait. Yeah, I just want to lay down now. I think I fell asleep before. I was thinking. Feels like I fell asleep. Wow. You know what's funny? I'm just thinking about it's totally unrelated, but someone was going on about yeah, I'm sorry. Someone was going on about there was this video of a fellow who was interviewing students on campus and asked them about, oh, would you want to pay taxes to have illegal immigrants get free education, right? And it's funny because it was like, yeah, would you think it's a basic human right to do that? And they all said yes, the students. And then when they were asked, oh, hey, do you want to? So we're gathering money right now for that purpose. Would you be interested in donating? And almost no one said yes. They all said, I don't have any money, more or less. And some of them made the mistake of saying, I don't have any money on me. And then they said, well, do you have Venmo? Can you just Venmo me some money? I think one person said, I'll Venmo you. I think we got one out of 8, whatever it was, a whole bunch. And I thought it was funny, it's like, It's like, yeah, everybody should have everything they could ever ask for, but as long as someone else pays for it. It's this funny thing where it's like somehow there's this disconnect between the taxes you're gonna have to pay and reality. Um, like I pay something like $2,000 a month in just straight taxes. Um, I think a lot of people don't really realize that or recognize that, particularly young people. That like that's it's a lot of money, and it only increases as you make more money, right? Like you're going to be paying at least 2,000. Like I wonder if you told all the students at school, like, hey, as soon as you get out of college and start making money, you're going to pay about 2,000 a month in taxes. Um, and then that's only going to increase over time. Like, are you sure that we should have all these programs? It's like, I don't know how much money you currently make, but when I was a student, I was not making 2,000 a month. I wasn't making anywhere near that. And the irony of it all is that really all it is just delaying, just wasting everyone's time, ultimately. What's really ironic is the position I'm in. The only way that I can even afford, the only way that the company I'm at can afford to make enough money to pay someone like me the wage that they pay me, is that they themselves are, what's the word? Are, how do you express that? They themselves are, what's the word? How do you say that? Serving the very same institutions that all these students are buying into, because that's the only way to make money, like this kind of money. You know, it's that if everyone's paying, look, I'm going to pay $200,000 for my education, then the only one who has 200,000, they're $200,000 in debt. The other $200,000 is guaranteed by the government to the university. So the university is the one spending $200,000. So the universities are the only ones that have any money. Same thing. The public education system is the first step towards the universities, right? All of this stuff is connected. It's all government programs, all publicly run corrupt programs. Just throw that word in there because it is horrendously corrupt. But it's all basically just brainwashing the kids to give up their future so that people in the government right now and people serving the government now can have easy lives and easy jobs. It's really disgusting and really sad, and it's like it's on my mind. You know, I'm obviously I'm thinking about all these other problems I'm trying to work on, but I'm kind of like, and I happen to be one of the people that just got lucky enough to be like, oh, now I'm making part of that money, rather than, so I'm one of these people with one of these quote unquote easy jobs. And it's kind of hysterical because the only reason that I have this job and it's quote unquote easy is because it was done in such a way that it's so challenging to hire someone and get them up to speed with the system that like they can't not pay. You know, like it's really hard for them to actually hire people. Like I've noticed that it's sort of like a revolving door of people over there, and very few people actually understand the inner workings of the system. Not to mention they leave on top of it. You know, they learn about it and then leave, and then no one else has any idea what to do or how to operate it, and so they have to pay pretty significant portion of their income over there to hire people. It's kind of crazy. It's kind of wild. Like I don't, you know, and the thing that gets me though is like my point is that they could have done things in a more efficient way in theory and not have to pay so much for something that's not worth that much. But because we're in this system where people are basically paying tons of money for stuff they don't need, it's like inflation. That's kind of what I'm getting at. Like it's creating this sort of pseudo inflation where the whole system is broken, start to finish, and like even though my job is easy, it's not easy enough to just hire someone for cheap, so they can't actually benefit from all the money that they're getting. They have to just I don't know if that makes sense, but it's kind of like it puts the economy in a weird position where like it's gonna just, I don't know, like it's not really a lot of value actually being provided here. Like it's just slowing the economy down. Like that's kind of it. It's kind of bottom line. It's just slowing it down to like a crawl. And I guess I'm one of the fortunate few that like I'm making enough where I'm not actually crawling, but everybody else is in some sense crawling, or will be soon enough. Something like that. I don't know. It's really weird. It's really strange. I think Trump being in office, though, it's he's gonna start changing a lot of this stuff, because obviously the public education system is only like the really obviously egregious spot where this stuff is happening. But I think probably all over the economy, there's all kinds of wicked things that have been put in place that are just nothing but detrimental to the economy as a whole. And Trump being in there, I think he'll do a lot to bring a lot of that out, remove a lot of that, which is great. So I think overall the economy is going to go up, but it's pretty devastating what's happened to like my generation. They were kind of encouraged to give up their lives for really nothing. It seems. There's also like sins, you know. I mean, obviously this stuff doesn't happen in a vacuum. It's not like the government is doing this without the consent of the people. That's something also to remember. It's like, yeah, well, also how and why did this happen in the first place? It's like, right, the sins of man, you know. It's not like there's sort of no reason to be that upset about it, because it's sort of expected. So something like that, right? Like you expect men to be wicked, and you expect the previous generation to sell out the next generation, something like that. Yeah. By the way, these are like all the things I'm thinking about while I'm trying to solve these problems. It's pretty bad. It's kind of funny, but you can imagine why I want to lay down. You can imagine why I just want to like just take a breather. Just hold on. There's a lot of other things on my mind here that I just can't. They shouldn't really be on my mind, I guess, but they're there, and they're definitely taking up space. They're kind of exhausting, all this stuff to think about. It's definitely exhausting. Just thinking about the problems of the day. Problems of the day. Whew. Anyway, alright, let's get back to it. Let's get some coding done here. I set out a goal. The goal was program all these problems, do my best, try to keep at it until I get through them all. And we're getting closer. We're getting there. So yeah, we'll just continue. And I did set it in my mind that if I have time, or what is it? Not if I have time. That I did set in my mind that I will take my time. Right? We'll take my time. I think I'm right to sort of take God's wisdom, take God's or to what is it, observe God's wisdom, and take the lead from God. Take the lead from God. Not try to force anything here. Just go slowly, carefully, right? Patiently, patient with yourself. Don't be angry, right? I mean, that's so silly. Really think about angry about a math problem. You kidding? Are you serious with that? What's wrong with you? Do you not remember the Stoics talking about anger being evil? And here you are, angry of all things over a math problem. It's very silly. Very silly. All right, so let's code up that solution. I think I got here. Okay. So, yeah, this is gonna be kind of involved, huh? Yeah, forget all this. Forget all this. So we're gonna write a subroutine that's gonna say palindromes with digits, or digit palindromes. I don't know what to call this. Like a sub palindrome? I don't know. I don't really want to say it's sort of digit palindrome or something. Like, it just doesn't seem to make a lot of sense. Just subroutine that generates palindromes. And we're going to say digits, or num digits. And we're also going to say lower bound. All right, that's what I was describing before. And now here, we can also use a let. And we're going to say there's going to be two things depending on an if statement. So first thing is going to be, no, let's not do it this way. Well, yeah, okay, that's fine. There's going to be two if statements inside here, but that's fine. So we're going to say sort of beginning of the range. And we're going to say there's going to be a function, right? Function beginning. Now, what we're going to do is going to say if even number of digits. Now we're going to define the function a certain way as well as the lower bound. Otherwise, we're going to define the function in a different way and have a different beginning for our lower bound. That's the trick here. So we'll begin with. Let's just talk about the beginning because we were describing that before. So if we've got this lower bound to consider, what we can do, if it's even, is we could take that lower bound, convert it to a string, take exactly half. Can I just half the sequence? Is that a thing? Clojure. Oh. Clojure is horribly unsafe. Uh-oh. 14 months with Clojure. Living Clojure. Uh-oh. State of Clojure. Split out? Probably not. I don't want to split. We could just take n. Yeah. We need half. Yeah, I mean, could also say lower bound is string. Why do I think because I just don't want to do that multiple times. So we can do take of, it's going to be divide by 2. It's even, so we don't need to lower bound as string. Count of the lower bound as string. And we can do that, and then concatenate this. Does this work? Can I do it this way? Let's open up the REPL here. And we want to, we'll just say like ABCD or something here. Not what we want. Oh, hold on a second. Hold on. Okay, I just want to mute the mic for a period of time. Oh, actually, this function is what. This actually is the function you apply to. Right. So if you're dealing with, excuse me, if you're dealing with, I have this wrong. This is the particular function you apply if you're even or odd, and then what you want is, I think maybe you just want to get that function defined, and then you have this initial sort of mirror sequence. Really should be an integer. And actually this even will handle, this will handle correctly the odd or even case for what this is. And then this actually you would, in order to, you would either increment or decrement depending on applying what happens when you apply this function. So this is actually not quite the way to do this. Yeah, it goes something like this. We'll say if, kind of have the wrong idea here. Something of the wrong idea. Something like the wrong idea here. Okay. So you get a function, anonymous, and what you're going to get is some value. And what you want to do is you want to convert this value to a string of value, also string of value. Reverse the string if it's your even number of digits, concatenate, make it concatenate the two strings. I think, yeah, I don't know if this will give us what I want. We use like 1, 2, 3 with this. I don't know. We have the REPL open here, so we can. One, 2, 3, 3, 2, 1. I mean, that's what we want. Yeah, that's fine. Right. And the difference is here, you'll drop this value, right? Okay, maybe not that. And let's say 1, 2, 3. I see. Drop 1. Yeah, that's what we want. Okay, that's fine. And then we say lower bound is a string, half lower bound count, mirror string sequence, initial sort of, yeah, whatever mirror string sequence we'll call it, take half. And then we'll say, you kind of want to convert this to an integer. So we'll say big int of apply string. Kind of want to test this part. We can do that later, I suppose. When we test the subpalindrome function, we'll test this part as well. This is coming out to be a lot more coding than I thought it would be. Yeah, it's kind of been a lot of effort for this problem. That's fine. I mean, it is what it is. Okay, lower bound is string, half this lower bound count. Fine. This will be not the mirror string sequence, but the beginning value. Beginning value, or just beginning. All right, we get this function, and then now we say, okay, we're going to reassign beginning. We say if function of value, which is beginning, if this is greater than, if this is, now it's, does this say at least equal to? Oops. Not less than n. So greater than equal to n. Okay. Not less than, greater than equal to. So okay, if this is, if func of beginning is greater than or equal to the lower bound, then we can keep it. Otherwise, we got to increment. All right, kind of, we talked that out before, that this is going to be a one-off at worst case, and you can just check if it's off by 1. Okay, great. Now that we've got our function defined, we've got the beginning defined, we need only, which by the way we could, yeah, I mean this is, it's kind of a lot of stuff going on for this portion. We can then take this range from the beginning to the end. We have to calculate as well. We have to calculate 2 values as well. We have default begin and default end, which this is, so we've got this half lower bound count, right? It's basically math power half lower bound count. We take 10 raised to this power decremented. So if we're starting with 3 digits, right, we're going to want 10 squared. This is the default beginning, and convert that to an integer. Doesn't need to be a big integer. And then the default end is the same thing, except just 1 order of magnitude above. And the reason why we don't need to subtract 1 here is that this range is exclusive. So we don't need to, it'll automatically subtract the 1 there. And then we can just take the maximum of the beginning and the default beginning. Right. Obviously, if we're too low here, then we'll take the default beginning. If we're way too high, or even beyond the default end, then this range will just give us empty range. And then obviously, if we're somewhere between the default beginning and the default end, then we'll have the sort of correct beginning. Now we simply map this function over each of these values. And there you go. That should give us our palindrome subroutine. So we test this by running subpalindrome over number of digits in a lower bound. So we can just say number of digits is 1 and lower bound will make it 4. Right, this should give us 4 to 9, I think. So we'll see. I could just print this. See what happens if we do this. Also, we should read these forum posts about state of Clojure. We don't need to see that. Hacker News, some 2017. A couple problems can be traced back to this problem. It's the language itself. Really? Clojure to Racket, another Lisp I've been using for projects for a few years. Racket is a better language overall, maybe less practical. Lacks some of the nice features Clojure brings, and many of these nice features are available as libraries. Most Lisps, including eLisp and Common Lisp. I used Stump WM as my window manager. Common Lisp. Common Lisp is better than Clojure. It's definitely stranger. Really? Emacs. Okay, I'm not really a fan of Emacs, but that's fine. It's largely because I don't use it. I think if I used it more, I'd probably appreciate it more. I realize I'm now reading the post and I wasn't going to do that, but here I am. Here we are. Here we are. Let me try switching to the other. Alright, reconnected, hopefully. Are we back? There we go. Alright, so I don't know what's going on, but my internet connection here is real spotty. I don't know why. It's kind of annoying. Anyway, we'll just finish reading this. 14 months with Clojure. Oh, nice. Oh, I wanted to, oh, this is a upvote? Okay, that's not what I wanted, but alright. Perspective, Clojure doesn't seem to be exceptional in any aspect, doesn't have nice features, but I bet it feels much better than compared to Java, but it also has some downsides which are irritating when coming from Racket or Lisp. It's common. Lost track of the number of people who've formed a negative opinion because they're forced to pick up the pieces from a half-baked project. Wasn't familiar with the idioms. Should not actually reflect poorly on the language. I mean, doesn't matter what language you operate in. If you have people who are kind of inexperienced, it's going to be not great. I mean, that's every language is like that. And I think everybody's had experiences like that. Gift that keeps on giving. Boils down to the problem I have with Clojure in general. Unmaintainable spaghetti code gets worse over time. But that's all code though. That's all code. Everything is like that. Patch on fixes that do the heavy lifting and try to figure out what's the original author trying to do, and they do it like this. How do we create the same functionality and prove it works with these rubbish tests? Only test the individual units of work, not the application. I mean, this is all this is all code. This is everything. This is why is it all one giant file? That's kind of this is every programming language. This is just programming. This is just problems with programming. Well, how many code bases have you actually seen, though? You know? Now, granted, because I've only seen a few. Like I've seen, well, really, technically one. I've only worked at one company, so I don't know. You know, obviously there was a lot of people working on the code base. The code base is a few million lines of code. So I wonder, like I wonder, like I wouldn't say this because I know I've only worked on one code base, and I'd have to be like switching companies every 6 months to really have a good data set to work with to say something like this. I doubt this is totally well informed. Because you can make this statement. This is technically not an incorrect statement. It's just he may only be looking at, you know, one Clojure database or one Clojure code base compared to, you know, I don't know, some other code bases. It's like you only have one of them to look at. I mean, I think every code base descends into chaos, one point or another. I think it's just part of professional development. Never using it professionally again. Might argue it doesn't reflect on the language, but I think it does. Well, it's not the language as much as familiarity, more likely than not. Like, cause I've noticed as I'm working through it, it's just like other languages where if you're not super familiar, you're going to run into a lot of issues. Yeah, it's more an issue of familiarity than anything else. But in my opinion, I do think Clojure is sort of somewhat more ideal than other languages because it's functional, and functional programming languages tend to have, there's a certain impetus put on avoiding like mutability related problems, which are extremely difficult to deal with once they prop up, which I like that a lot. I think that's actually generally like a positive aspect of Clojure and functional programming, is this kind of genuine attempt to reduce these sort of mutability related issues. When you're dealing with sort of race conditions and things being changed in other parts of the code that you're not really aware of. And actually, even just today, even this week, there was a developer who was telling me about an issue where he was trying to work with one part of the code that appeared to be referenced in another part of the code, and he's thinking the other part of the code is trying to dereference this object, trying to free this object, and then his code is trying to free the object as well, and it's causing the program to crash, right, causing serious problems. And obviously it's C++. It's actually a mix of C and C++ code, and it's pretty serious. Like, it takes time. It takes, like, these developers are not working for free. I mean, we're talking for days he's working on this problem, and I think devs, it's like, you get paid a few $100s a day. So yeah, that's a real expensive problem, right? That's talking, 12 could be $1,200 that if he's getting paid, say he's getting paid $400 a day, and he's working on it for 3 days, it's $1,200 problem. Just because you want to use lots and lots of mutability in your code. Granted, you do pay a price for that. There's a price to be paid, but obviously one of the prices you could see is that you have to pay is just learning the language itself. Getting familiar with the code. Like, it basically makes all of the regular problems of programming harder. Just getting the code to work right in the first place. But if you're really skilled and you're really familiar, that shouldn't be too bad. You could argue that's the same thing for the race conditions and the mutability related issues, but I don't think so. I think it takes a lot more time, like an order of magnitude more time and more cost to debug mutability related issues and sort of race condition type of issues, because of how components interact with each other when you combine things. It's really, I really think the beauty is when it comes to combining stuff. I guess I'm assuming that's probably it. It's when you start extending your code. That's where the maintainability really becomes much better for a functional language. I guess in theory. Like, I don't actually know. Realistically. I mean, I don't have because I've been working with Clojure for the past few weeks, and I've been running into a lot of issues. Not so much issues with the language. I think more of issues of, like, I think programming is just kind of hard in that problems are hard, like real problems are hard, and it almost doesn't matter what language you're operating in, it's going to be hard. It's just Clojure allows you to have sort of a less problem. It'll be slightly less hard. It's still going to be hard, if that makes sense. Because the problems I ran into, like, because obviously I'm not mutating anything. I'm not using any multi-threading stuff at all. So I haven't even gotten into that. So, like, the issues I'm running into are really just issues with programming in Clojure in the first place, right? And I do have some complaints, one of them being, like, the debug messages can be kind of vague. Although, like, I don't really know how you can improve that too much, though, because it's like compiler errors, and compilers are not, they can't really know what your program's trying to do because they're compiling the program that you wrote. Does that make sense? Because it's kind of like, you know, you're thinking of something, and then you're trying to code it, but the program, the compiler can't know what you're thinking, right? Like it can't use you as an oracle to figure out. So you kind of got to work with the compiler. So it's not really a problem with Clojure. I think it's just, I don't know, writing code in general has that element of it. It's just kind of difficult when you don't have the right idea, or like, because that's really there's two like big problems when you're writing code. Is one big problem is, do you have the right solution to the problem? Like, is the thing you're planning to code actually going to solve whatever use case you're considering? That's the first problem, which is extremely difficult to begin with, right? Right, this tremendous diversity and tremendous numbers of pitfalls in just that alone. The second part is, once you've actually coded this solution, or you've got your solution, now you're going to code it, you've coded it, does that code, is that actually compilable code, syntactically correct, and does it match what you originally thought to do, right? Like, does it actually do what you even designed it to do, right? There's like the design in the first place, and then there's the actual implementation of the design. And those don't always match, right? Like that's kind of a lot of the issues that I was running into, both of those issues, right? I was running into my designs were incorrect because I was unfamiliar with these problems, which has nothing to do with Clojure, which sounds a lot like what they're complaining about. And then also I'm somewhat unfamiliar with Clojure, and so my implementation of those designs were also kind of poor. So there's just difficulty of programming inherently, which all of these things are not really Clojure issues. Like I've seen all these problems in other languages. C++ has all the same stuff. You know, like this is not a language specific question. Why did they do it this way? Like that's that's an organizational issue. That's a he didn't comment his code, and he didn't explain to you what particular challenges he was. You know, you're not inside the previous programmer's mind. Which I kind of was hoping that, like, I don't have a good solution to that. You know, that's actually a really good question that is pervasive across software development. Why? The proverbial why. It's really an interesting one. It's definitely a pain point that could use some help. Now, I thought that Clojure might help with this question, perhaps, by making your code simpler. But I guess not. I guess it doesn't really matter. I guess it really is just like experience of how experienced is the developer, and how succinct did he make a solution, and how well explained and how easily explainable and easy to understand is his code ultimately. But I would agree. I think the language is harder to get familiar with than other languages. But that's not even really totally true, right? Because C++ is so gigantic that you could say you can't really top C++ in terms of getting familiar with it. So it kind of doesn't matter. I don't know. I think maybe Clojure might be easier to get familiar with than, I don't know. I don't really know. So he's saying sections of bad code have a disproportionately negative effect compared to other languages on the surrounding code, and negatively impact the entire project's code quality. I'm not really sure. I mean, I don't know. I couldn't tell you one way or the other. It's usually pretty bad. It's also really subjective measurement here. It's like, well, how do you measure the effect, the negative effect? Hack something out for a deadline. Better go back, clean it up. If you don't, the code base is in a bad spot. My experience on 3 different code bases. All right, it's only been 3. It's not that many. You know, you kind of got to go through like thousands. Whew. complaining about type checks repeatedly. I mean, JavaScript though, you know, like F#. I think there's a guy that I work with that works on F#, and he likes it, prefers it over Clojure for the same reason, type checks. That might be true. I mean, maybe I should be learning F#. I thought about that. Not to switch back to Clojure. Interesting. Yeah, okay, this is kind of what I was saying. That's what I was thinking. Parallelize all the things. Squeezing them through Rube Goldberg machines. Yeah, it's kind of what it feels like programming Clojure, at least the way I've been doing it. Abusing Ruby metaprogramming. Interesting. Only in good Clojure code. Tell me you've never picked up a piece of Clojure code and gone, what the heck does this do? What are these global channels for? Why is the whole application constantly updating a top level full application state atom? Why are we blocking indefinitely with some magical invisible state hidden in a Clojure as we iterate over a collection of objects to process? So you have a beautiful Clojure code base, it's fantastic, but ideally you just learn to not do that. How do you fix a bad code base when the functions aren't pure global injections, global channels, or quote unquote pure only in the sense that input is the entire application state, including non-pure objects like a database handle, or your functions are non-deterministic due to some kind of producer-consumer race condition? Yikes, I get it. Don't do that. But what do you do when it's too late? Someone has already made those bad decisions. You're stuck. Where are the debugging tools to help you figure out what's going on, and the refactoring tools to help isolate code units and replace them? I mean, sure, you could argue that it's an issue in any language, but all I can say is that I've used a lot of other languages. Only similar experience I've had was working with Perl. I mean, like, I don't know. It's kind of like complaining that someone's using it incorrectly. It's like you could do that with anything, you know. Like, it's not really the problem of the language. Maybe it doesn't have safeguards to prevent people from doing those things. You could argue. I guess that's kind of fair because like there's a lot of overhead associated. Yeah, I don't know. Kind of back and forth on this. Does it really matter ultimately what language you program in? Does it really matter? I do wonder that. I've been learning Clojure recently, but I'm wondering if this is even worth the time. I do wonder. A whole application constantly updating the top level full application state atom. All right, I already read that. Something that would help the Clojure community improve, especially with regard to introducing Clojure to a team, is to ask why this kind of thing doesn't happen in Python. I know Python doesn't come with atoms, but you could certainly stick the whole application state in a global variable. You wouldn't, though, if you're a working programmer with a modicum of experience on your first Python project. If people just see some new idioms and forget everything they already knew about programming. Python does have closures, and you certainly could write one that blocks due to some hidden state or just something stupid involving multi-threading. This isn't seen as a problem with the language, though. It's seen as a sign that the person who did it might need to work more closely with someone more experienced, or that the team needs better code reviews. That's what Omnext did to great success. Whole app state in a global variable. That's pretty funny. Misunderstood your argument. You're not implying a single state is bad. You're saying there is nothing in Python to deal with it. Interesting, I suppose. Depending on global atom, your functions aren't pure at all in any sense, or even using functional programming. It should be represented as single root storage, application data store, database, and the interactions with it should be controlled and sanitized. Have 1,000 little places across your code base updating and reading from the database. It's horrible code too in Java or in Clojure. Modern UI frameworks are carefully controlled access and update to the display state for UI. They happen in a controlled and orderly manner, specifically to prevent chaos you get otherwise. If not, you're doing it wrong. Section is in the OM docs, covers their solution, which is quite elegant. Notice you don't just reach out and update atoms directly by hand. There's nothing wrong with having a global application state. It's a good thing, but directly interacting with it is not. Interesting. Interesting. Closer to it, the first time, it's usually a mistake to stick your whole application state in something resembling a God object. Client side of a single page application might be exception under some circumstances when the language provides some tools. Well, I like React Redux. I've used Redux. That's what I've actually, this is the experience I had explicitly for using single page application with Redux to handle the state, managing the state. Worked out reasonably well. No language I've used is exempt from the possibility of people writing bad code. No stopping a determined person from writing bad code. Big difference between various languages and how easy it is to accidentally or unknowingly write bad code. Is it really that big of a difference? I would argue it's really highly specific to the situation you're dealing with. Like, how familiar is the person with the different variables that are meaningful? Like, i.e., the different technologies that they're working with in that particular problem space. Like, how familiar is that person with respect to those problems? And then also, how familiar are they with that particular language that they're going to program in to solve that said problem? Right? Like, that's pretty much how you unwittingly or unknowingly or accidentally make a mistake, is that you're just not familiar enough to know what would be the pitfalls to avoid. Maybe that you've been unlucky. I've been using Clojure for 9 years now, and the majority of code bases I've worked on have been very clean. My experience is that Clojure tends to produce flat code bases, whereas object-oriented languages produce code bases that tend to be deeply nested. Yeah, this is something I would appreciate a lot. So I've dealt with a code base that's deeply nested, and it sucks. Because documentation is sparse and the code base is deeply nested, so you just kind of get lost very quickly when you're trying to figure out what a program is doing. Yeah, I don't like that. I give that a big old dislike. Can't prove any of this, it's all anecdotal, but I thought I'd mention that your experience might not be typical. Well, even the guy's experience is anecdotal. Like, he said he only had worked on 3 code bases. So it's not a lot of code bases to analyze. All right. Yeah. Yeah, I don't know. Is this using the Lord's name in vain? I do wonder if this counts as cursing. It's blasphemy. I know it's a joke. Like I know what it means. It means how terrible would it be if someone had to. But even to make a joke, it's like, should you really invoke God's name? I question that. Because you could just say, how terrible would it be if someone had to learn map, reduce, and filter? Oh, how terrible. And interesting. Interesting. Some positive reviews, some negative reviews. I don't know. 14 months of Clojure and he didn't like it that much, I guess. Horribly unsafe. Spent a year and half the time we were fixing bugs if someone had wrapped a map in another map or changed the shape of a data structure. It's worth it. Rather use JavaScript to add insult to injury the amount of wasted time on something easily checked by a compiler in a sane type system. There's all the bad habits you acquire when the general lack of confidence in your code. It took 6 months to cure. Sticking with types. Thank you very much. Interesting. Needed schema. Sure, the shape and contents of the map. And be turned off for production use. So I come back to Clojure every time if I need anything that's available as a library. Need better type safety, add in what you need, a macro or two. Not really possible easily with JavaScript. There's TypeScript, JavaScript exists. So it only gives you a single dimension of safety. Also safe. There's also Clojure has a spec for specification. I like these dimensions of safety, right? Thread safety, immutability, reference exceptions. I like that a lot. In a live, real-life Clojure system that had to be maintained and supported, not a hobby, happy, slappy project thing caused by putting square pegs in a round hole. Telling me I need to get a macro-based library. As opposed to using a language with types. Really? Oh, guess what? I'm sure there's a JavaScript library that does that too. Dependently typed language in production. I don't use anything in production. Nice. It's very funny. I don't know what dependent typing means. Second reference to God we saw. Also, yeah, this seems a little bit less tasteful. I think this does count as blasphemy, using God's name in vain. Yeah. Oh, third time. Okay. Agree to disagree. Do not enjoy the impossible to prove defensive coding around threads and callbacks. Vocal about having a truly bad experience, even from other people who prefer strongly typed language. Mostly seeing them expressing it as not their taste, rather than actively dislike it. Sharing experience. JS as an alternative in terms of typing. It's borderline one of the worst type systems out there. Similarly unsafe. Well, it doesn't have, it's dynamically typed, right? So I guess it's the same complaint I've seen, is that people don't really like dynamic typing because it's kind of hard to track down exactly what it was that the type was or is. Which I guess is a fair point. I kind of prefer dynamic typing because I don't like constantly specifying what my types are. But I guess when you're dealing with very large data structures, I guess it starts to get cumbersome. I probably I'm probably gonna end up feeling the same pain point if I ever used Clojure professionally. I'm still not even there yet to using it professionally. I just want to learn it, just so I know it. And then, I thought I might want to use it professionally because I thought I might want to like try out Clojure job. But the more I hear about, the more I learn about programming and finagle with programming, the more I'm kind of like, this should only ever be used as like a tool to achieve something, some goal. Nothing more, nothing less. Only ever program as much as you absolutely need to survive. Something like that. I'm getting to that point of like, I don't know how I feel about programming. Been doing it for 12 years since I was 15, and it's like, yeah, it's when it's a hobby, it's great, but as professionally, it's just, there's a lot of stuff to consider. It's just a lot of stuff, I guess. But anyway, spending some time learning Clojure, I think it was a good time. I mean, I'm glad I did it. Glad I learned it. It's better than wasting my time on whatever else I might waste my time on. Oh yeah, let's finish this problem though, and then I think I'll probably just end stream after if I finish this sooner rather than later. I was gonna say I felt like the problems that I was solving were taking me a lot longer because I was doing it in Clojure, but I don't think that's entirely true. I think I didn't fully understand the questions that I was working on. I thought they were easier than they were. It's probably more likely. There's definitely a certain degree of like not being familiar with Clojure, like as experienced or familiar, but that I think is sort of minor in comparison to like the first major issue is actually knowing a solution to the problem. Second major issue is coding it up in Clojure, which, yeah, like I said, I'm still getting kind of familiar with Clojure, but I think most of the difficulty with solving these problems has been actually from the problems themselves, which is fine. I mean, I think they're reasonable, overall reasonable. Oh yeah, so we just wanted to test this. All right, digits in this context, num digits. Yeah. Whoa. 4, 5, 6, 7, 8, 9. Oh. Don't need that. Don't need that just yet. There we go. Sweet. Nice. It works. Amazing. Okay. Wow. Holy smokes, dude! That was like one shot. Literally one attempt for that. That's amazing. That's really cool. Holy smokes! Wow, I just like coded that up. So, no problem. No problem. Hold on. Let's do like 3 digits and let's do like 400 and see what happens here. I wonder. Wow. That's pretty cool. It works, man. Looks correct. I don't know if it's correct. I think it is. These all look like palindromes. Is this all the palindromes? I hope so. That's pretty cool. Now if I go over 1,000, and then I go over, I'll give it a second, then I'll go under, I'll go to 99. So over 1,000 we start at 1,1. Now I think this was supposed to start at 0 rather than 1. What did I do? Wait a second. Oh. Oh, that's interesting. Uh-oh. Uh-oh. I gave it 1,000, right? This should have been empty. Hold on, does it do? Okay, it's not correct. All right. Okay, I was gonna say, yeah. So this is like an example of, I was talking about that, where like I have the wrong idea here. It's not Clojure at all. It's just having the wrong idea. Whoa. Okay, it's got to be greater than the lower bound. I done goofed. Okay, maybe. Uh-oh. Maybe I do need to drop. Huh. Well, this is kind of awkward. I think, So we could just throw a drop while in front here and forget about figuring out the beginning of the sequence. And don't worry about it. Should still be efficient enough for our use case. But I think there's a problem here, right? Shucks. The lower bound, that's the problem. This doesn't have anything to do with the lower bound you're given, but the beginning does. And you'd say the maximum begin the beginning and the default begin. Now the default begin, it's not the lower bound count actually. It's the number of digits. It's actually half the number of digits. Right. Half the digit count. Which is a little different. Thought maybe I needed more references to the digits, number of digits here. This has got to be half of the digit count. There we go. Try that now. I think that might be a little bit better. Okay, good. We got what we're expecting. And now if we put 1,000 in there, what do we get? It should be empty. Not empty. Okay, interesting. And then if we put like 500 in there. So it's kind of interesting that we did end up incrementing the beginning from 10 to 11 when we were over, and we also, so this is now kind of incorrect. Function of beginning, and then we increment the beginning. If this is larger than the lower bound, then we have to increment by 1 to make sure we're at least. Yeah, right. If we're not larger than the lower bound, then we need to increment by 1. But what was being suggested is that so we put 1,000 in there to make it the lower bound. And then we said, okay, the default begin. Now that's kind of interesting. If the digit count is 3, and we take 2 here, then this default beginning is what? It's, think about this for a moment. Because this loops from 10 to 99, it should be, right? So this should be 10, right? Digit count 3, we get 2, minus 1 is 1, right? This is 10. Then 3 to 2, this is 100. Default then is 99. The maximum of the beginning and the default beginning, which is 10, and so this beginning, the lower bound of 100 or 1,000 actually put us at, well, that's kind of interesting because we ended up with 10 because it was the number of digits in the lower bound. Oh, huh. That's not correct, is it? That's not correct. No. No, 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 no. No, sir. Don't work like that. It don't work like that. Right. How do we, yeah, like this is going back to what I was saying about, like, this has more to do with understanding of the problem, familiarity with the problem, than it does with programming it. Programming it probably is pretty easy if you really understand the problem. Let's think about it. Shucks. This is kind of funny. Because we divide by 2. It only really works when you're dealing with odd values too. You divide by 2 on the lower bound to get you this beginning. Assuming the lower bound is within the range. I guess you just have to perform that check, that the lower bound is between this default begin and default end. If you apply function all 3 of these and just check. Yeah, apply function all three of these, and then check that the initial lower bound is between those two results, or just apply it to these two. And really, it should be at just the end. If it's greater than or equal to this default end, then you know, set the beginning way off. Otherwise, it doesn't really matter, I think. That's the only case where you really have an issue. If you're too small, it doesn't really matter. But if you're too large, you could run into this situation that we see here. Yeah, I mean, yeah, all right, we'll just do that. So we'll say default begin func or palindrome. Default end palindrome, which would be just func of default begin default end, and we'll say, we'll actually just define beginning and end here. The ending is always the same, really the thing that changes at the beginning. So we'll call begin, we'll say beginning default end. It's going to be, let's say if, or just condition, I think. So otherwise condition we'll get to in a second. But we're going to say if default begin palindrome, no, this lower bound. Yeah, this lower bound is below the default beginning palindrome, then the beginning is going to be default begin. If we're greater than or equal to the default end palindrome, then we're going to say this is default end and skip everything. Otherwise, just beginning as it was described. I think this will get us what we're after. All right, so we can try these different use cases here. We have 9500, we have 99, we have 1000, and let's see what we get in each of these cases. Hopefully it gives us what we're after. So for 500 we get this, 99 we get this, and 1000 it should be empty. Come on, man. What is going on? You gotta be kidding me. You've gotta be kidding me. What? Come on, man. Okay. Jeez Louise. This range should be empty. Yeah, you should get the default end here. This doesn't even fire. 1000 is definitely greater than or equal to default end. Oh, this is, that's kind of interesting. I'm really confused now. What did, what did I do, man? All right, so we get these different cases. Nice. One more time. One more time. Okay. Oh, because this is 10,001, this default end palindrome. Uh-huh. Whoops. Maybe that's why. Maybe that's why. There we go. Now it's working. Okay, yeah, because there's kind of a big difference because we're creating the palindrome out of this value, so you gotta use the correct one. You can't just use the end complete ending value. Okay, got it. Right. Gotcha. Okay, try again. See if we get what we expect for these three. Should get like half of the range here, full range here, and then none of the range there. Nice. Now if we do like 998, right? Should still get what we're after here. Should just get 999 at the end. Okay, good. Good. And finally, so there's a case where you have like you have 102, or rather 201, 102. So 201 and 102. So what I was suggesting is that the next palindrome here is what you want. So 201 and 102. Let's try those two. This case, the beginning of select should be correct immediately. This case, it should be 11. So for 201, 102, first one immediately, and then the next one is, right, 11. Yeah, okay, that's correct. That's this logic here. This part should handle these cases correctly. All right, great. Now we can we're about to get off here. We're going to take our sub palindrome. We're going to map cat over this. So map cat over range. Keep it real simple. Just say call this sub palindrome, and we're going to use the number of digits. You can also drop the first. You can start from 1 digit. So the number of digits is going to be, right, and the lower bound is going to be passed through from the top level. That's what we want to use for palindromic sequence. Let's see how we do. See if this even works. Oh, interesting. Okay. Seems correct. Oh, not quite. Nope. 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 can be greater than or equal to the lower bound. Shucks, man. Shoot. And we're supposed to include something there that we did not include. Subpalindrome of 1 digit 0. What do we get? Ooh. One through 9. We should have 0 here. 0 should be part of this. Shucks. You know, I don't know. What do we get for begin here? Thought it was too good to be true that my function would work right off the bat. So there's no way. There's no way. So I think we got the beginning here, and then we also want to get this part. Now that's kind of interesting. These are both 0. So this is fine, right? That logic is incorporated correctly. But the issue we ran into was, or is, oh, because the default begin. Oh, I didn't think of that. Right. The first 2-digit number is a power of 10. The first 1-digit number is not a power of 10. I didn't even think of that. Oh, that's very interesting. Wow. Huh. So actually, it's just this beginning is wrong. No kidding. Wow. I didn't think of that. I did not think of that. Huh. And you gotta make a special case for, wow, amazing. All right. Amazing. Oh, no. Mm-hmm. Yeah. Amazing. Amazing. I think we get rid of this stuff. Probably even go back to what we had here. Let's try again. Zero to 161. Is that what we expect? Yeah, looks like it. Okay, it's pretty good so far. Let's try. Scared to try these other cases because I want to go. I want to go. Need to use the bathroom, and my relatives are coming soon to say hello. So I'm a little scared here. False, true, true. What happened here? Maybe this is not supposed to be this one. Or no. Wait, what are these? Oh. Got true for most of them. 1, 2, 3, 4, 5, and 6 seem to be incorrect here. 1, 2, 3, 4. All right. There's a 5 here, 6 and a 7. 1, 2, 3, 4, 5, 6, 7. Let's say 1, 2, 3, 4. And I'll get rid of these. 5. Oops. And there's also a 6 and a 7. 6 and a 7. All right, there we go. Okay, let's try this now. Now we hope this doesn't time out. That is our hope. No, come on. You gotta be kidding me. No. No. Oh, I don't think they time out, it's just this one is incorrect. This one is actually just false. This is ridiculous. No. 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 I gotta investigate this now. This is probably gonna take me more than 5 minutes to do. Shucks. I have to come back to this. May have to come back to this. Great. I thought I was so clever, man. I thought I was so clever. I thought it was good to go. I thought it was good. So there's this set of 199 palindromes, and there's this other set of things, which looks like we're going to take the range from 0 to 10,000, and then take this first of the palindromic sequence from 0 to 10,000, and take a set, and that should be, these should be equal. I don't know about that, man. I don't know about all that, you know? So what number? So that's kind of interesting. They both stop at 1991 at the end, and they both start at 0. So where are they different? Nine two nine 1661 8558 121 949 32. They look the same. Where's the difference? Where are they different exactly? Would you please explain? I'm at a loss here. Is this not the one that's, no, it's the one that's false. True, true, false. Huh. Huh. Yeah, I mean, just double check this is the one that's coming up false. Let's verify. That's something I often do too when it comes to troubleshooting, problem solving, and all that. Do lots and lots of verification. It says false. Okay. Yeah, so this is the one that's false. Why though? Why is it false? Can we take the disjunction of the set difference here between these two sets? Print that. We'll take the first set and then remove the second. And then reverse that and go in the other direction. Take the second set and remove the first. And see what we get. One of these should be empty, right? Well, we'll see. We'll just see what we get. We got the false, 9. And 10,001. So one of these sets has a 10,001 that the other one doesn't have, and the other one has a 9 that the other doesn't have. You gotta be kidding me. Excuse me. Well, I think I'll come back to this, but how is that even possible? That are not less than n. So maybe I made a mistake somewhere here. Why? So we're expecting in the second set to have a 9, this one, and we're expecting in this first set, also in the second set, we're expecting 10,001, right? So this set has 10,001, and then this one that the other one doesn't, or this set rather, has 10,001 that the other one doesn't have. And this set has a 9, which the other one doesn't have. So maybe we're expecting this one to have a 9 as well as 10,001. I don't know. Which one's missing the 9? That's interesting, but that's the differences between these two sets. There's a 9 and a 10,001. Interesting. I think I'll end stream here. My relatives are coming over, so I'll see them soon. Thank you all for watching. Talk to you soon. Have a good rest of your day. And yeah, I don't know what the deal is with this. It's 9 and 10,001 shenanigans here. I don't know. There's something going on here. Something funky. I thought I had pretty clean, flawless logic here. Thought I had it, but I guess not. I guess something's wrong. Something to do with the bounds, the edges, and the edge cases. That's what we'll call them. Something's not right. Very interesting. It's kind of weird. I don't know. I don't know what's missing. It's odd. It's really odd. But yeah, we'll look at it later. So, all right. Take care. Take care.